When it's hot, cities can feel unbearable. You're chasing shade, heading for green spaces, or escaping into air-conditioned buildings. Well, that's because during hot weather, cities are often warmer than the countryside around them. And not just slightly warmer, sometimes much hotter. So what's going on? Well, today we're breaking down one of the most important and increasingly relevant weather phenomena, the urban heat island effect. And we'll test it, comparing surfaces like grass and concrete, and learn about heat in cities that could be better forecast in the future. The urban heat island effect simply means that towns and cities are often warmer than the nearby countryside. Cities can be several degrees warmer, sometimes 8 to 10 degrees Celsius under some meteorological conditions. And what's particularly interesting is that the difference is often bigger at night than during the day. So even when rural areas cool down quickly on a hot day, cities hold on to the heat, which can significantly impact human health as well as infrastructure during heat waves. Heatwave intensity and frequency is increasing worldwide due to climate change. And with over 50% of the population living in urban areas, the urban heat island effect is of increasing importance to better forecast and understand. Well, how do you guys find the heat?
We really like it.
I really like it.
Yeah.
It's nice to have a bit of a change from our classic English weather. So it's
Nice to
but
get a tan.
sometimes it does get a bit too hot in cities, especially.
Do you notice that it can feel a lot hotter in a city compared to even just being in the park?
I mean, probably. There's more buildings, more people about. It kind of heat gets trapped. So yeah, probably.
First, and probably the biggest factor, is what cities are made of. Concrete, asphalt, bricks. These are all dark surfaces that absorb a lot more of the sun's energy. So during the day, roads and buildings act like giant heat sponges, storing energy that gets released later on. Now compare that to grass or countryside, which reflects more energy and stays cooler.
When it's very hot, then yeah, that does slow me down. So I'm less productive when it's very hot.
You just drink more, put some sun cream on, wear a hat and stay indoors if it's too much, and open a window by a fan.
Next, cities have far less vegetation. In rural areas, plants and soil cool the air through evaporation, releasing water vapour and taking heat away from the surface. It's a bit like sweating, it cools things down. But in cities, we've replaced the grass with trees and pavement and buildings, so the natural air conditioning system is largely lost.
I think the summer actually starts a lot before the summer holidays now, like the actual heat of the summer. But by the time you get to August, September, it's not as nice as it used to be. I think everything's shifting.
It's shifting,
I think so.
You're noticing a change to our seasons.
Well, I'm from London anyway, originally. I know in the city it's really, really hot. There's no open spaces. You just kind of skip the heat.
Then there's the structure of cities themselves. Tall buildings create what's known as an urban canyon. They trap heat, reflect it between surfaces and reduce airflow, so warm air can't escape. So instead of heat dispersing, it builds up right where people live.
So the city's the last place you want to be.
Definitely the beaches.
The beach.
Get a
or-
nice tan.
Yeah.
I'll sit in a nice warm shade, so
Yeah.
some people love to sit in the sun, and I just think skin cancer these days, so I tend to stay away. But
There's also a heat contribution from human activity itself. Things like transport, buildings and air conditioning systems release heat into the local environment. But at night, the countryside cools quickly. Cities don't. That's because buildings and roads slowly release the heat they've stored during the day, keeping temperatures higher overnight. That's why the biggest contrast between city and countryside temperatures is actually often at night. Let's actually see this effect. Here we've got two surfaces, grass and concrete. Look at the difference. The concrete is noticeably warmer, and that's exactly what we've been talking about. It absorbs and stores heat much more efficiently, while the grass stays cooler, partly because of evaporation and shading. Now scale this up across a whole city, and you can see how the effect really starts to add up. Have you noticed a change in sort of over the years that you've
Oh,
seen
definitely.
summers?
It's obvious. Yeah, I think it's definitely getting warmer for longer.
Yeah.
Yeah.
And the spikes in the heat are also getting higher as well. You notice it?
Yes, absolutely. Yeah, I mean, it's in the news, isn't it? So
Yeah.
Yeah, definitely.
I'm 70 now, and there were 4 seasons when I was a kid and a teenager, and they were very definitive 4 seasons. And now you don't. Well, you might get 4 seasons in one day. You
Yeah.
know? So, yeah, it's definitely changing. There's no question.
We do seem to have more severe weather perhaps when it happens. You know, maybe the temperature's a little bit higher.
Yeah.
A few more floods.
Yes.
You know.
Exactly.
But then how much is that gone in a cycle? You know, I'm not really sure.
This isn't just an interesting weather fact, it has real consequences. Heat in cities can lead to heat exhaustion, heat stroke, and even increased deaths during heat waves. Warm or tropical nights are particularly important because they prevent the body from recovering from the heat during the day. High temperatures in cities also affect crime, energy networks and demand, as well as transportation, as tarmac can melt and rail tracks buckle.
The one thing I've noticed is air pollution. You know,
Yeah.
I suffer with hay fever now, older in life than I ever did before.
Yeah.
And I'm aware every day to look and see what the warning is for air pollution.
Definitely seems to be getting warmer. Yeah.
Yeah, getting warmer, and then obviously we're getting all the rain as well. So it's just one or the other, really, isn't it?
As global temperatures rise, the urban heat island effect can make heat waves even more intense in cities. More people are also living in urban areas, meaning that more people are being exposed to these higher urban temperatures. So understanding and monitoring this effect is key to designing safer cities for the future. And here's where things get really interesting, because understanding urban heat isn't just about explaining it, it's about predicting it. And forecasting heat in cities is challenging because temperatures can change dramatically over short distances. But new Met Office research shows how this is improving. Scientists have combined traditional weather forecasts with citizen observations and land use data using machine learning. This approach improved temperature predictions by around 11% and increased detail from kilometres down to 100 metres. Thanks so much for chatting to me today, Lewis. Just wanted to talk about your research. First of all, could you just explain what it's all about? What was the question that you were trying to answer with your research?
Yeah, so the simple question was, can we better predict temperatures within our cities at a much finer scale than traditional weather forecasts? So cities are super complex environments. You can have a park, a busy road, a river, and dense buildings all within a few hundred metres of each other. And those features can create very different temperatures. And traditional weather forecasts do a great job of predicting the overall weather, but it's difficult to capture all of those local variations. Modern weather forecast models are really sophisticated and actually really good, but they have to represent the atmosphere using grid boxes. So for operational forecasts across the UK, these grid boxes can be typically much larger than individual streets or neighbourhoods. So a single grid box might contain parks, roads, rivers, buildings, all of which influence temperature differently. And as a result, forecasts can sometimes miss the local temperature variations that people experience on the ground. And that's important during heat waves when those local differences can be quite big.
So you mentioned you've got it at a finer detail by using machine learning and citizen observations as well. So more observations and the machine learning. How does the machine learning come into it?
So basically, heat's not distributed evenly across the city. Two locations that are a few hundred metres apart can be quite different due to things like shade, vegetation, building density, etc. And the idea is that we're going to use the machine learning to learn from that sort of those local variations in conditions and from observations. So they tell us what the weather's like in those different locations. And then the machine learning learns that and can add the detail based on what it's learned in the past. One exciting application is combining detailed heat forecasts with maps of vulnerable populations. So that could help local authorities identify neighbourhoods that may be most at risk during a heat wave and then target support where it's most needed. There's also potential benefits for industry and infrastructure. So extreme heat can affect outdoor workers and place stress on things like transport networks. So knowing where the hottest conditions are likely to occur could help organisations prepare and respond more effectively.
So instead of forecasting heat across a whole city, we can start to understand it street by street. Which makes sense because even small differences in surfaces or shade can change temperatures significantly. And this matters because better forecasts mean better preparation. It allows cities to target vulnerable areas, plan cooling measures, and respond more effectively to heat waves. And in a warming climate, that kind of precision could help save lives. So why is it warmer in cities? Well, it comes down to 4 key things: dark surfaces absorbing more heat, less vegetation and less cooling, buildings trapping heat and blocking airflow, and heat being released slowly overnight. If you enjoyed this video, give it a like, and if you're not already subscribed to our channel, make sure you are so you get notified when we release more explainer videos like these. Have you ever heard of the Föhn effect? It's another phenomenon that can dramatically vary the temperature over a few miles. Alex explains all here.